Hello friends, myself Dr.M.K.Gokhroo, Department Mathematics, Government College Ajmer. In my previous lecture, I just introduced the genesis of special theory of relativity. And we have seen that there was a conflict between Newtonian and electromagnetic theories. And the concept of relativity was that in all inertial frames, physical law remains same, but in electrodynamics, it does not follow, does not hold. Therefore, there must there it is feeling of the scientific community that there must be some modification in this type of thinking. And later on, the modification was made by scientists, and in particular Einstein gave us the special theory of relativity, and later on the general theory of relativity. So, first of all, we try to understand the basic problem. The concept which was going on at that time was that all physical law must remain the same in every inertial frame, and for the sake of this, I define, or in literature it is available, that there are inertial and non-inertial frames, about which I talked in my earlier lecture. So, inertial frames are those frames in which the motion of particle or any physical laws remain the same, or an accelerated body seems unaccelerated, whereas non-inertial frames are those frames which are in which the unaccelerated body or particle moves with uniform velocity looks like that it is accelerated. And we have seen two transformation for this. To understand the theory, we define two types of transformations from one coordinate, and here the coordinate system has its importance to know the entire theory of relativity. So, the coordinate system of reference frame, which is the basic entity for this, we should know it completely. So, yesterday I defined the spatial Galilean transformations. And then general Galilean spatial and general Galilean transformations. Means the position of a particle in two inertial frames. Position of a particle in two inertial frames are given in two different ways. Spatial, here we took the spatial Galilean transformation as one frame is moving with respect to other one with velocity v in a particular direction or in an nx direction, then the coordinate of a point in two different frames, the transformation equation was written. And in the similar way, if one frame is moving with uniform velocity with reference to other frame in a straight line or in a particular direction, not along the axis of first frame, that is a inertial frame, we have taken the space general Galilean. We have seen the transformation equations for a particle or for a point in general Galilean transformations. Today we are trying to explore the things about the physical laws, whether they remain same in one coordinate system or in other coordinate system, or in one frame or in other frame, which are inertial ones. So the first and foremost basic entity of physical law, that is the distance between 2 points. Distance between 2 points in a frame, say, is a inertial frame. The coordinate of these 2 points with respect to this frame x, y and z are given by x1, y1 and z1, and the coordinate of other point is say x2, y2 and z2. These are the coordinate of 2 points. So distance between these 2 points, say P and Q are 2 points, then the distance between these 2 points are given by PQ is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the distance formula for any 2 points in one coordinate system. Now, if this is assumed to be an inertial frame and another frame moving with initial velocity, with a velocity v, whose x-axis is along the axis, this frame, the second frame is moving along x-axis such that after time t it is moving with velocity v, and after time t its distance from O to O dash is vt. So this is x dash, this is y dash and this is z dash. The coordinate of this point with reference to this frame, second inertial frame, is say x1 dash, y1 dash and z1 dash, and coordinate of this point is say x2 dash, y2 dash and z2 dash. Then the distance between these 2 points A will be given in second frame. In second frame, distance between these 2 points PQ is given by under root x2 dash minus x1 dash whole square plus y2 dash minus y1 dash whole square plus z2 dash minus z1 dash whole square this is the distance between 2 points to same points P and Q in second coordinate system. Now, what happens? Whether this distance is observed to be same in one coordinate or in other coordinate. Is it true or not? We have to verify this one. So, from special Galilean transformations, we know that x1 dash is equal to x1 minus vt. Since this second train is moving with velocity v along x-axis, so x1 dash is x1 minus vt. x1 y1 dash is nothing but y1, since it is y-axis is parallel to this one, so y1 dash is equal to y1 y1, and z1 dash is equal to z1. And in the similar way, that the point x2 dash is equal to x2 minus vt, and y2 dash is equal to y2, and z2 dash is equal to z2. So, what is PQ now? From here, PQ will be equal to x2 dash minus x1 dash, means x2 minus vt whole square, x2 minus x1 x1 minus vt whole square, x2 dash minus x1 dash whole square plus y2 dash, y2 means y2 dash is nothing but y2, and y1 dash is nothing but y1, and plus z2 dash is z2, z2 dash is z2 minus z1 square. This is the square. So this is the distance PQ in second coordinate system, and it is nothing but Vt and Vt cancels out, and x2 minus x1. This is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. It is the same entity as here. So distance between 2 points in 2 different inertial planes remains same. So distance, this physical law, distance is same in every inertial plane. Thus we can say it. Second, if you are given special Galilean transformations or 2 inertial frames related with special Galilean transformations, 2 inertial frames, and we want to see whether the second law of motion is same for 2 inertial frames. Means second law of motion. Now we have to study this law of motion is same in 2 inertial frames or not. We have to study this. So let us take the first frame as usual with x-axis, y-axis and z-axis origin in O, and we are choosing the special Galilean transformation. Later on we can choose the general Galilean transformation or Galilean frames as well. So this is x dash and it is y dash and it is z dash. O dash is here. Special Galilean transformation. Now a particle say is here feeling some force, say F is the force which is feeling by this particle means if a force is applied on this particle with reference to this particle. This exert a force, this particle exert a force F, and let us say its component in all the three coordinate system means x-axis, y-axis and z-axis, means component of F and along x-axis is Fx, along y-axis is Fy, and along, I should not write like this, these are not coordinates but are the components. So these are the components of F along x-axis, y-axis and z-axis, along y-axis and z-axis. Now the second law of motion is F P is equal to F is equal to ma. Fx along x-axis its component, I am writing here with reference to components. So Fx is equal to m. In Newtonian mechanics, we assume that mass is absolute, remains same forever. So Fx is equal to m, and along with that d2x over dt square along with x direction, a component of acceleration along x direction. Similarly, Fy will be equal to m d2x or d2y over dt square, and Fz is equal to m d2z over dt square. This is what about the force exerted by this particle from this particle. So in the component form, I can write this second law of motion as this. Now, in second coordinate system, its coordinate in first coordinate system, its coordinate are x, y, z, and second coordinate system, in second inertial plane, its coordinate of this point, say x dash, y dash, and z dash. So x dash, we can write the transformation between these two is x dash as a special Galilean transformation, x dash x minus bt, y dash is equal to y, and z dash is equal to z. So dx dash upon dt, dx dash upon dt is equal to dx upon dt minus v, and later on second differential will be the same. Second differential will be the same. So how can I write this one in terms of components? I must write d2x x dash is equal to d2 x dash is equal to dt square is equal to d2x over dt square d2y or dash over dt square is equal to d2y over dt square, and d2z dash upon dt square is equal to d2z of d2z over dt square. This is what I can write. So the equation, this portion, m d2x over dt square, I can write m d2x dash upon dt square, and this is m d2y dash upon dt square, and this is m d2z over z dash over dt square. So that portion is equal. Now this different this force exerted by this particle is through this particle is the variation of potential. Potential. So force exerted by this particle is proportional to this distance between these two particles. So potential V is proportional. V is the function of R. V is potential and potential is a function of R. So R in first coordinate system, VR in first coordinate system is given by R square. Say its coordinate in first coordinate system is x1, y1 and z1. So R square is equal to x minus x1 whole square plus 1 or x1. This is the fixed point, this is moving point. So say it is x1 minus x, y1 minus y whole square plus z1 minus z whole square. I may write in different way x minus x1 also, since it is a square of these quantities. So R is a function of R. So I can write this, and in second coordinate system R dash, its coordinate are x dash, y dash and z dash. So in second coordinate, we know the distance function is same. In earlier example I have taken this, the distance between two particles remains same in every inertial frame, therefore it is the same. R is same in second coordinate also, and R in second coordinate system, if potential is V dash is a function of R dash, V potential is same, V is a function of R dash, and R dash distance between these two, R dash square is given by, so its coordinate is in second coordinate system is say x0, y0 and z0. So this is x0 minus x, x0 minus x dash, rather to say x dash square plus y0 minus y dash square plus z0 minus z dash square. R dash square is given by this relation. So now what about potential? Fx is equal to this is Fx in first coordinate system of first frame, it is nothing but minus del v over del x. Fy is in first frame of reference, it is minus del v over del y, and in first frame it is minus del v over del z. These are the potential in first coordinate system. So del v upon del x dash. Now what about del v over del x dash? X dash. Del v over del x dash. What about these? See, del v over del x dash will be equal to del dv over this. I can write dv over dr dash and del r dash over del x dash. This I can write. Del v over del x dash will be equal to del v. Now in second frame, v the function of r dash, v the function of r dash, and del r dash over del x dash, and this I can write dv over dr r, since r and r dash are equal, so I can write dv over dr, and what is dr over dr dash? Del r dash over del x dash. from here, del r dash over del x dash, I can calculate twice del x 0 minus x dash, twice of this one, twice r dash and del r dash over del x dash equal to twice of x0 x naught minus x dash and minus, or we can take it plus since it is square. So x0 minus x dash minus I must write, I say x dash minus x0, y dash minus y0 and z dash minus z0. So this is your x dash minus x0, x dash minus x0 twice of this one, and other parts will be equal to 0. So del r dash over del x dash is equal to x dash minus x0 upon r dash. So instead of this, I can write x dash minus x0 upon r dash. Now this is what, this is about the x dash minus x0, means x dash minus x0 in second coordinate system. This is the difference with x component of x coordinate. So x dash minus x0 upon r dash, and dv over dr, r is same for these two planes. So I can write x minus x0 and x component of, since the distance is same, so x component in first plane is equal to x component in second plane. So I may write this is equal to dv over dr and x minus x1 upon r and x minus x1 upon r in complete form. This is nothing but del v over del x. This is your r. So this I can write del v over del x. This I can write del v over del x, dv over dr and x minus x1 upon r, and x component of this is nothing but the x component in first coordinate system and divided by r is given by this. So rate of change of potential along x axis is dv del v over del x in first coordinate, means rate of change of potential with reference to along x axis is equal to rate of change of potential with respect to x dash axis, or in second frame they are same. So here it is same, fx is in second coordinate system or in second frame, I can write fx is equal to minus del v over del x dash x dash is equal to n d2x dash over dt square and all remaining 2 terms. So this suggests that the law of motion, second law of motion, has the same components in two reference frame, two inertial frames. So law of motion is a physical law. Physical law remains the same in one inertial coordinate system. It will be the same in other coordinate system. So in two inertial frames, in these physical law remains the same. Now inertial frames means moving along a particular direction or particular velocity with reference to one frame to other. But if a frame is rotated, say this is a frame, this is a frame, this is a frame. Now, let us suppose that this frame is rotates about z axis, So after time t, the x-axis takes this form, this place, means after time t, x-axis moves to this position, y-axis moves to this position. So this is your y dash and this is your x dash. So let us try to define this is moving with angular velocity, and since this movement is in with time t, so it takes time t, so angle will be omega t and omega t. So in t times the frame takes another position, that is x-axis, z-axis remains the same. So we have two coordinate system now, OXYZ, OXYZ, this is one coordinate system, and the second one is OX dash, Y dash, and Z dash is same. Z dash is same. So in these two coordinate system, we have to study whether these two frames are inertial or non-inertial. So let us try to study these two frames. Let the coordinate of this point with reference to first coordinate system is x, y, and z. And in second coordinate system, coordinate of this point is say x dash, y dash, and z dash. In these two frames, the coordinate of the same point P, say point P is here. The coordinate in first coordinate system of this point P is x, y, z, and in second coordinate system it is x dash, y dash, and z dash. Then what is the relation between x dash and x? X dash will be equal to x is moving with an omega t angle, so x cos omega t. X cos omega t and y sin omega t. Physically, let us try to understand the things that we have x-axis in this direction, y-axis in this direction, and z-axis in this direction. So, x-axis, y-axis. After rotation, this x-axis takes this form, y-axis in this direction, so this makes an omega t angle, and this makes an omega. Suppose the location of this point is P point is this one. So z dash and z remains the same. For this and this is moving in plane section only. So x dash and y dash are different, but z dash is equal to z. Means the perpendicular from this point to this axis, this plane containing x, y axis will be equal to x dash, y dash axis. The z coordinate is same. Now what about x and y coordinate? So we know from our earlier studies that x dash, earlier studied about coordinate axis changing in coordinate system. So x dash will be x cos omega t. and plus y sine omega t, and y dash will be equal to y dash is x minus x sine omega t. It is minus x sine omega t plus y cos omega t, and z dash will be equal to z. This is the transformation of one coordinate system to another. Now what happens? Dx dash upon dt is equal to dx upon dt and cos omega t plus dy over dt sin omega t plus differentiation x as it is, and differentiation of cos omega t is minus sin omega t, and omega t means omega, plus y as it is, and sin differentiation of sin omega t is cos omega t, and omega t, differentiation of omega t is omega. So I may write here x omega takes outside from this, and this is minus sin x sin omega t plus y cos omega t, and this is nothing but omega, this is your y dash, omega y dash. So dx dash upon dt gives us these two terms plus omega y dash. Omega, it should be omega y dash. So I may write here plus omega y. In the similar way, if we find d2x, dy dash over dt is equal to dy dash over dt is equal to I must write dx over dt sin omega t plus dy over dt cos omega t plus or minus whatever it may. This term like this will be equal to minus omega x dash, minus omega x dash. And what about zx? Z differentiation of zx will dz over dz dash over dt will be equal to dz over dt. Again differentiating this, I will get d2, I am writing a d2x dash over dt square is equal to, I am writing straightforward d2x d2x dash x d2x over dt square, d2x over dt square cos omega t plus d2y over dt square sin omega t plus some 2 or 3 terms d2y sin omega t, omega square y dash plus one more term appears, that is 2 omega dy over dt, that is 2 omega dy dash over dt. These are the 4 terms dy dash over dt, and similarly from here we can calculate d2y dash over dt square is equal to d2x over dt square, d2x over dt square sin omega t minus, it will be minus, I think this will be minus, so it is minus, and plus d2y over dt square and cos omega t plus or minus y, the omega square plus y square, omega square y dash plus omega, it must be omega square x dash. Here it must be x dash, and here it is omega square y dash, and here it is minus 2 omega dx dash, 2 omega dx dash over dt, and the third one is as it is d2 y, d2 z dash over dt square will be equal to dz or d2z over dt square. So if we are taking these two frames to be inertial, then or acceleration is 0 in first coordinate, if acceleration is 0 in first coordinate system, means if we have this term acceleration is 0, means first frame is inertial one, then this term will disappear. This term and this term will appear. This is same. So this is 0. Acceleration along z-axis is 0. So we can see from here that acceleration in first frame is 0. Acceleration of the particle is 0 in first frame. Even then, acceleration is appears here. This term and this term shows that there is acceleration of the particle in second frame. So these two frames are non-inertial. Why? Because of the particle is accelerated in first frame, appears to be accelerated in second frame. So this type of frames which are rotating are not inertial frame. From here we can see this. Thank you to all for today's lecture.